Hi, welcome back to my channel. Hope you are doing good. Today I'm going to talk about Kubernetes part 2. I hope I have covered part 1 with what is Kubernetes, history of Kubernetes, what are the benefits which we are going to get it. Today let's understand a few more concepts and then we can understand the real hands-on session. Okay, let's jump in. So Kubernetes basically uses a configuration file that they call it as manifest file that is represented in a YAML notation. YAML means yet another markup language. So you have a structure defined by the Kubernetes. We're supposed to follow the Kubernetes manifest file structure and then start building those manifest files to deploy any of our application onto the Kubernetes engine. Okay, so Kubernetes majorly they used a term called kind. Kind is basically used to drive a specific feature of the Kubernetes functionality which is running on the Kubernetes engine. So we can describe here only few of the services. I'm not going to describe all those because it is a big bunch. Please try to go ahead and learn by yourself. So if you look at it, Kubernetes kind types varies based on the purpose. Say if I want to run as a pod, that is called a container. Okay, and if you want to expose that container ports to the application, call it as a service. And deployment nothing but if you want to deploy more than one containerized image onto the container, yes, you can do that. So there are different types which are there. So here I am specifying few of that. Namespace is one kind. Pod is another kind. In a moment I am going to describe in a ML file. Okay, just try to understand at this moment. Service, config map. If you want to define key value pairs, you can define NodePort. Say if your applications, the front end applications required to talk to the NodePort, so to the backend service. So NodePort is the single point contact for the front end applications or browser applications or load balancer. You can choose either NodePort or load balancer. And replication controller, say that when I'm hosting my container, I wanted to host it 3 copies of the same container. Yes, you can definitely do it, which can run on the same port. And deployment, likewise, there are different varieties of kinds are there. I'm just depicting few of that. Okay, namespace is basically used to create with respect to your application so that you can define the resource quota for your application needs. So that's where you will host all of your applications belonging. Say in the organization you have many applications running. Say app 1, app 2. Say app 1 contains say 5 microservices. So we cannot host it in a default namespace. We supposed to create one specific namespace. In that namespace, we will host all 5 microservices so that it is easy to manage and maintain the life cycle of your pods, services, whatever it is. So that's the reason this namespace is being used. And disks, say that you are running a container image. There are certain things you wanted to say, there is a file which is available. You wanted to load that content in your Java application. How can you do it? You need to have that file mounted on the physical server, and then that you need to link with the pod instance so that you can able to read the content of the file based on the logic which is written by the developers. Not only Java, I'm saying any kind of a language, C, C++, Java, whatever it is. So they have what type of a storage class could be used. Say if it is a Google GCP has their own If it is a Azure has their own, like that you can specify what kind of a storage class. And the major kinds are persistent volume, which is defining the volume, and pod is going to use that persistent volume claim by that kind, so that you can link your hard disk which attach it to your physical server to your pod. So those are the few classes which I have specified for the kind. And say you wanted to control specific users groups, right? Such kind of a things called as access control. Such things you can also map with kind. Role mapping policy, you can specify what kind of a policy this particular namespace can have, and so forth. Say that your pods are keep preserving some data. For example, if you wanted to host Cassandra database, or if it is required to host, say, RabbitMQ, so such instances definitely require the stateful session. So state of the object or the data has to retain, right? Even though if a particular pod crashes, you should not lose the data. That's the reason you need such kind of a stateful preservation. So such kind of a kind also available. So these are few samples which I'm representing according to this demonstration. Please try to read. Okay. So if you look at it, as I said, Kubernetes manifest file represented using YAML, yet another markup language, either YAML extension or .yml. Both of the extensions allowed to work. So this is the standard signature defined by the Kubernetes. So we're supposed to follow that, and then we have to build it. API version. So we have to specify what kind of version. This can be keep changing or constant, depends on the Kubernetes, because this is an open source. We should follow according to those releases, follow the documentation, and come up with building this kind of a manifest files. And now I can say that this is the kind I was referring earlier, a kind. This is called kind. So here I am specifying pod. Here I can define a metadata, like what is the purpose of this particular pod kind. So I'm specifying name Java Web, and I'm defining labels, and the name of the label is Java Web. This is very, very useful whenever we are hosting the applications. So this can be used as a selector. I will explain you from this service file. And this is the specification, and this is the container, and the name of the container is Java Web. This is the image which I have stored in the Docker's public registry, which I have given one of the demonstration. Please follow that and try to understand how to customize a Docker image. So this is the image I am going to pull. This image contains a Java which is installed, and I am binding a simple Spring Boot jar to run as an application, and image pull policy if not present. Say I don't want to every time pull from the internet. If it is not available, it is required to pull it. If it is already available, it will just start. And what is the port which is going to run that particular? I'm declaring as a container port 8080 Tomcat, right? So the Spring Boot by default it uses 8080 support. So this is a pod kind declaration. Now I cannot directly access the pod. To access the pod, I need a service. So via service, I can able to access this particular port. So I am defining that API version v1, and the kind, if you look at it here, service. This is the service kind, and metadata name is Java Web -service I am specifying. Now I am specifying a specification. Here, if you keenly observe, selector. So this is the standard name app.kubernetes.io/name, which is my pod to connect to get for which is running in the pod port. So for that significance recognition purpose, we use this selector. That's the reason I am specified in this particular exercise, label name is mandatory if I wanted to map this pod service pod to the external service name to map to get access from the outside of this Kubernetes engine. So I'm specifying that name as Java Web, whatever the label's name is there. I supposed to map exactly the name. If that name is not matching, it is not going to get that. And ports, I am specifying that protocol TCP and port is 8082, target port is 8080. This is the port which is running Tomcat, so that is called target port. The service is going to use 8082. That means from the web application, from my browser, I use localhost colon 8082 like that to access it. If I have the external IP address that is where publicly exposed to the service level, then yes, I can specify that the IP address of that node where it is running the Kubernetes engine. So that is the understanding of the Kubernetes manifest file. Please try to understand these labels must match with the selector. Without that, it will not work as expected. Though this is a sample which I'm giving you. Likewise, we need to build a lot of configuration files for your development. So here, if you look at it, Kubernetes deployment architecture, ideal architecture look like this. So you have one computer for master, one computer for node 1, the other computer for node 2, other computer for node 3, where you wanted to host your actual pods which can run on these 3 nodes. Pod never runs on this node. This is how ideal architecture look like. So this is very important to understand the fundamentals. But in my demonstration, I'm going to have all 4 of the fundamentals incorporated into a single machine, and that I am running for the demonstration purpose. So if you look at it, servers up and running, Windows host OS, Linux VM guest OS, which is running in my Windows, and Minikube. I'm using Minikube is a software provided by the Kubernetes, where people can try to test locally without really installing cluster like the previous one which you have seen like this. Okay, and I have hosted a Spring Boot pod service in this demonstration. So how do we test? We can test using Linux terminals URL, or from my Windows machine I can port forward and then I can test. And if I want to see whether my pod properly started or not, I can also do the inspect the logs. Okay, so this is my Windows PC, the outer box. So here I am running a virtual box which is running Linux guest OS, and in this Linux guest OS I'm using Kubernetes port forwarding 8082 to 8080. That is where my Minikube is running the Spring Boot application. Okay, so this is the use case integration architecture physically which is running in my machine on a single machine. I am not having deployment like 3 node or 4 node like the deployment architecture. So the prerequisites are Docker public registry images access. That is very important. Yesterday I have posted one of the video. You can go ahead and visit a playlist Docker. Underneath I have clearly specified. And Kubernetes locally up and running engine. Here I am using Minikube and internet connection. The intended audience are Java developers, medium to high skill, or architects, whoever is interested. So these are the reference links if you want. This is the image instructions were given. Please follow and try to host it. So that's all about the part 2, the conceptually. Now let's dive into the real hands-on session. So here I have some configuration files wherein I have to follow certain ground routes because I am running all these in a single virtual machine environment. So to fulfill that, I am going to use this kind of a deployment process to demonstrate. In the real environment, you can use like java web.ml, java web-service.ml kind of syntaxes for deploying. So that is also possible to create instance, but that cannot be accessed outside of the Kubernetes. That's the reason I am following certain standards which is supported by the Minikube. This is a strict prohibited direct access to my service. That's the reason I'm going with a different syntax of the hosting. So let me take the instruction set. So this is the instruction set file which I'm referring. You can see it. So first, say this is my name of application. Say I'm creating a namespace ns-real-time. This is the namespace where I'm going to host. I can create, after created, I can see that get namespace. So here I can say Kubernetes get namespace. So this will list all the namespaces which are available. See, you can see default. This is Kubernetes node lease, Kubernetes public, Kubernetes system, and NS Narayana. I have created one namespace. Now I have created one namespace. So now my namespace is ready. Okay. So wherein you can define quotas as well. Right now I am not defining any quotas. So you can try to understand what is meant by quota. So now I am creating a deployment of my Spring Boot, which I already created in the Docker registry. From the public, it is going to pull it. If it is already available, it is going to, okay, there is a spelling mistake. So here it is a real time, here it is a rela time. So now I have created a deployment. The deployment which is going to take care about pod as well. So if you look at it, now I issued a command on this namespace. What are the pods available? What are the services available? What are the deployments available? Now if you look at it, this is my Spring Boot. Pod is up by applying this command. Kubernetes namespace real-time create a deployment. That means my pod is up and running, it is ready, and it is also stating that it is ready. And this is a of a kind deployment, okay, from the conceptual wise. Now I cannot access this outside of my Linux server. That is the problem. So what I supposed to create? I supposed to create and expose a specific signature, because as I said, I'm running a Minikube. I have to follow the ground rules which is supported as per the instructions. If it is standard, 4-node cluster, then I can directly access it. That supports that kind of a notation, but here it will not give me such benefits. Now if you see that, now it is saying that the port 8080 has been exposed. It is saying. Now let me reissue the same command which I have issued before. So let me clear this for your visibility, and I can show you. So now you see that the pod is as usual and the deployment as usual. Now you see that service has been created, which is of a type load balancer, which I already described. So this cluster IP, and this is exposing on this external IP address, because now I can use curl and I can use this. My Tomcat is running on 8080. I can query. So my REST is returning this is home page. That means, yes, this is working as expected. But I cannot get this port outside because this IP address is provided by Kubernetes, but actual IP address of my host is different. Here you can see that there are a lot of ports which is running, but my IP address for this machine is, this is the one. But if you see, according to this IP address is provided automatically by the etcd, which we described in part 1 concept. That means for every pod it creates one IP address, and if I create a service that exposes that service on a different IP address, these things are internally which is doing by the Kubernetes engine. I cannot access it. To access from that minikube, I supposed to do a port forwarding of my service. So I am specifying that this is the namespace, this is the port forward I am doing it for the service. I am saying that from the external I am going to access 8082. Let internally take care the 8080 is the port. Let me take this 8082. Let me go to browser, say localhost. I say 8082. Now you can see that I have invoked a REST service which I have configured in the GitHub. You look at it. This is one of the, one of the Docker image. When I created it, I have a source code availability. In that, only one of the REST endpoint, that is home page. Other than that home page, nothing else which I have it. This is the name of the application which I have created a Docker image. Only one. This is get mapping. If you see this home page, this is home page. This is the message basically which is printing on the browser. That means I have created a custom based Docker image. I have published it to the Docker's public registry. From there, Kubernetes is going to pull that image based on the instructions which I am following according to the deployment which I shown to you before. So here the instructions were there. So now you have seen, right? So I'm creating a namespace with respect to application. One namespace will be created and quota limits or will be defined. This is my deployment structure. These are the commands used. Now let's see, can I able to see my Kubernetes pod log as expected pod. So I need to know the pod first. Okay. So exact pod name I supposed to need get pods. Okay. There is a spelling mistake. Real-time get pods. So this is the pod I have which is running. I want to see that whether this pod successfully started, but we wanted to see, ensure that this is working as expected. Otherwise, say if my web page is not working, that means there is some problem with Kubernetes. How can we troubleshoot it? This is the troubleshooting. This is the namespace. When I ran the deployment command, it created this pod. Whether successfully started or not, I wanted to see, means I had to inspect with the logs, or Kubernetes provides probes, initial probes, startup probes. Likewise, probes also provides. You can configure those and you can use it and test it. But here I'm making sure that my Tomcat started properly or not. This is the name of the application. You can see that, which I have shown from the GitHub. This is the application which I am running as an image, and it started. It is, you can read the instructions: starting service, Tomcat, starting engine, and then Spring Boot web application started, and then completed initialization. So this is the inspection of your pod, whether it's successfully running or not, so that you can make sure that your page is accessible from the browser. That is how can understand the real-time scenarios. So by following different softwares, different understandings, this is a mini kube, everything which is running on this node. Okay, so on a single machine, this is the single machine which is running Windows host, where I am running a virtual box. On that, it has a Linux. I am using Kubernetes commands to do the port forwarding, and then I have a mini kube which is running the real pod and service. Okay, that's all for the real time. This is a real small mini project which I created image. I pushed that image to Docker registry. I pulled from the Docker registry. I have hosted in my running Minikube engine. Okay. I hope you are enjoying to learn new things. Thanks for watching. Like it, share it, and subscribe it. I come up with a new video. Until then, see you. Thank you.